Hello. In this demo, we'd like to demonstrate Tachyum's capability of building high-speed networking at Exascale. Our industry-leading Prodigy system will rely on cutting-edge networking infrastructure. This leads to careful selection of building blocks and their interconnections. Let's start with a basic building block, the switch. What we have here is a 32-port edge-core switch powered by a Broadcom Tomahawk 3 chip. Every port is operating at 400 gigabits per second. That's 400 times the speed of common office networks. And our servers are interconnected using these superfast switches. The switch counterpart on the other side of the cable is a network card inside a server. The main cards we are using are dual-port Broadcom NICs. These cards can transmit on two 100 gigabit channels or aggregate traffic to 200 gigabits using one cable. One of the basic cable types we are using here is this straight cable that can connect 2 points by 200 gigabit speed. Another cable type is a breakout cable. This cable can split a single 400 gigabit link on one side into two 200 gig links or four 100 gig links, effectively connecting multiple different servers using a single switch port. There are multiple cable vendors and multiple cable types out there. Each one comes with its own pros and cons, and we are continuously testing many of them. These are samples of optical transceivers, active optical cables, active electrical cables, and direct attached copper cables. Let's see it in action. These servers are connected to the 400 gigabit edge-core switch using breakout cables. Each server has a 200 gigabit uplink to the switch to access other servers and network storage systems. Now, let's look at this network from the operating system's point of view. We are logged in to one of the servers we've just seen. Let's have a look at the Broadcom NIC. We can see it supports various speeds up to 200 gigabits in full duplex mode. The link is up and the auto-negotiated connection is established at the maximum speed. Okay, we have the Rocky kernel module loaded and enabled in the NIC card. After enabling RDMA support on the NIC card, we have the virtual InfiniBand interface created. This interface can now be used for Rocky traffic. But what is Rocky, you might ask? Let's have a closer look. Rocky stands for Remote Direct Memory Access over Converged Ethernet. This standard is Ethernet's response to its competitor, InfiniBand. Rocky allows extremely fast and low-latency data transfers over classic Ethernet links. Data is transferred directly from one server's memory to the memory of another server without the need of processor intervention. We will now compare network speeds between regular Ethernet and Rocky on our mid-range testing servers. Here, we have two terminals to servers connected to the edge-core switch we've seen. Let's look at the network interface and IP addresses. Both servers are on the same subnet connected to the switch by 200 gig links. If you look at the average packet latency, it's pretty impressive. Now let's see some throughput speeds. Okay, so we're getting about 41 gigabits of throughput using one link. We can try to use more streams, which means using more CPU cores. Well, that's better. Almost 90 gigabits. We can see complete saturation of the active CPU cores used for the transfer. If we try to use even more CPU cores, let's say 30, we get diminishing results on these mid-range servers. That's where Rocky comes into play. Let's see how performance improves when we bypass the CPU from the data transfer. And there we go, wonderful. We are getting a stable throughput of 23 gigabytes per second, going from one server over the edge-core switch to the other server. Let's quickly convert our measured 23 gigabytes into gigabits. Perfect. Thanks to Rocky, we're getting 186 gigabits throughput on a server that is CPU limited to 90 gigabits using classic Ethernet. We hope you found this demonstration interesting. Thank you for watching.